So now we'll look at the types of mean, or you may say approaches to obtaining the mean. The first one is the arithmetic mean. The arithmetic mean is the commonest of the types of mean. Now, it is the one that is usually used when you want to obtain the mean, but it is not the only one that can be used. Now, so it just has to do with adding everything and dividing the sum by the total number of observations. But then the geometric mean has its formula to be this. Now, please don't forget, or rather be mindful of the fact that this one can be used when you have non-frequency distributions. For instance, you just have three. It's not a frequency distribution, but you just have it like that. So, and then you have your data like this. All right, but it's a frequency distribution when what you have here, for instance, becomes 2. So maybe you put, this is the observation x. Let's have it this way, x. Then you have 2, you have 3, you have 4. We can actually have 1. We should have 1 first. So you have 1. Okay. And then you have f here. And then 1 shows 1 time, 2 shows 2 times, 3 shows 1 time, 4 shows 1 time, and then we also have 5 showing 1 time. So this is a frequency distribution. So in the situation where you have your data to be like this, then you can use this formula. It will be appropriate. That's what I'm trying to explain here by saying frequency distribution and non-frequency distribution. Maybe I should just leave this here for now so that anyone who wants to refer to it can. Alright, so the next kind of mean is the geometric mean. It is defined this way. Now, the symbol you see here, this symbol is actually a symbol that looks something like this. And it is called the multiplication symbol or the product sign. Now, so the product sign actually, just like this, is called, though it's the Greek word for this particular stuff that you see here is actually called sigma, but it stands here for summation. So sum from 1 to n. This one says multiply from 1 to n. So product. That's what you are seeing here. So there is something that I did not include here. There should be an n here. Okay, and here. Okay. There should be a root sign. So there should be a root sign here. Right? Sorry. Oh, okay. Okay, so what we are saying here is that we multiply the first observation by the second, and then by the third until you multiply all the observations. But there's going to be an end here. So let's take note of that. So the end root of the product of all the observations is what we call the geometric mean. So where n is the number of observations that you have. All right, so we go on. The harmonic mean is defined as, okay, please note that here we are actually, so raising each observation to the number of times it appears. So for instance, 1 raised to the power of 1, 2 raised to the power of 2, 3 raised to the power of 1, 4 raised to the power of 1, 5 raised to the power of 1. So you do 1 raised to the power of 1, you multiply by 2 raised to the power of 2, multiply by 3 raised to the power of 2, and so on and so forth until you are done. All right. looking at that, it's similar for the arithmetic mean. Don't forget, you're going to say f, so that will be in this f times x. So 1 multiplied by 1 plus 2 multiplied by 2 plus 1 multiplied by 3 plus 1 multiplied by, like that, until you're done. All right, so coming to the harmonic mean, okay, the geometric mean, we are doing a similar thing, but this time around, each observation will be raised to the frequency that it has. So x raised to the power of f. But here, we don't have a frequency distribution, so we just multiply each observation with the other. Each observation with the others that you have. So you just multiply, you multiply the observations 2 times 3 times 4 times 1 times 2 times 5. All right, the harmonic mean says, okay, no, look for the reciprocals of the numbers. So when you're dealing with the non-frequency distribution, you just look for the reciprocal of the numbers. So for instance, seeing that we have observations 2, 3, 4, you're just going to be doing, how many observations are there again? 1, 2, 3, 4, 5, 6. So you're just going to be saying 6 all over 1 over 2, the first observation. You have 3, 4, so you say 1 over 3 plus 1 over 4 until you're done writing all the observations. So, and that's how you go about that one. Now, but when you come to the frequency distribution, then what you're going to do is that you're going to say, okay, what's the frequency for the first observation? How many times does it appear? It appears 2 times, then you write 2 as the frequency, and you put 2 here. So for instance, let's look at what we have here. 1 appears 1 time, 2 appears 2 times. So you're going to say frequency of 1 is 1, so you put 1 there. So before then, you'd have written 6, 1 over 1. Then you go on to say 2. 2 is the observation, but it appears 2 times. So you go on and say, okay, the next observation is 3, but it appears 1 time. So you put 1 up, and then you put 3 here. Now, with that being said, that's just to let you know how the formula works. So let's go on and see an example. Given the weight of babies to be 3, 4, 2, 3, 4, 5, 4, 2, find the arithmetic, geometric, and harmonic mean of their weights. Now, going by that, because we don't have a frequency distribution, we may bring a frequency distribution out of this, but it's not a frequency distribution as it is now. It's just observations that we have, but have not been put into a frequency distribution form. Now, so we get the arithmetic mean by using the formula that you see here, and that will give us, so we add everything, 3 plus 4 plus 2 plus 3 plus 4 plus 5, and then we get 27 divided by 8. 8 is the number of observations, 1, 2, 3, 4, 5, 6, 7, 8. So that's how we got that, and then you get 3.375. But when we want to get the geometric mean, then the geometric mean, defined this way, will actually give us something like what we have on the board. So we are going to be multiplying everything that we have. Sorry about this. So we will multiply, okay, we need to multiply everything. So just look at it, the observations as before. So we multiply everything out, and then we look for the 8th root of everything. Now note something, there is no over anything there. So alright, this is how it should be. So multiply everything out and then look for the 8th root, and that will give us 1,000, or rather 11,520. The 8th root of 11,520 will give us 3.2187. Okay, so that's our geometric mean. Then we go on to the harmonic mean. The harmonic mean says look for the reciprocal of all those observations. So all we do is just say, okay, 1 over all the observations as we were given. So 1 over 3 plus 1 over 4 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus 1 over 4 plus 1 over 2. Now, so we divide 8 by the sum of all these reciprocals, and then we will eventually get, so we should have something like, it should be 8, the same 8 you are seeing here, divided by 157 over 60. So everything you have here should give you, here, in the denominator, should give you 157 divided by 60, and that in turn should give you 3.057. So it should give you 3.0573. All right, so haven't got that, we may progress. But what about a situation where we are giving the baby weights, the weights of the babies in a frequency distribution form? It could be any data, but we are using this just to illustrate the concept. Now, in that case, when you add all the frequencies, then you are going to have n to be the same thing as the summation of the frequencies, so that will be 8. All right, the number of observations will be 8. And that way we go on, and so each of the frequency will multiply by the weight value. So 2 multiplied by 2 in the first one, the frequency. So the next one, 2 multiplied, okay, this, I will need to swap this. I want you to take note of that. It should be 2 multiplied by 3. There's a reason why I'm particular about the order, to avoid. So to avoid issues that may come up when you're trying to interpret the formula. So the frequency should come first, considering the fact that we wrote f before x. So 2 multiplied by 2 in the first place, 2 multiplied by 3 in the second place, 3 multiplied by 4 in the third place, and 1 multiplied by 5 in the fifth place. So you go on, and you have 5 plus 6 plus 12, so this gives you 4, this gives you 6, this gives you 12, this gives you 5. So you add everything, and you have 27 divided by 8, and that will give you 3.75, and that was what we had the first time. Now the second time, to get the geometric mean now, look, let me duplicate this table. Now you can look at the table as I work it out. Now looking at the table, we are going to be looking for the 8th root of everything we have, all our observations raised to their frequencies. So 2 appears 2 times, so we write 2, this 2, raised to the power of these 2. So that's what we have here. Then we go on to 3. 3 appears 2 times, so this 3 raised to the power of 2. So 3 here, raised to the power of 2. So the frequency 2. All right, so 4. 4 here is this, and then raised to the power of 3. This is the 3, the frequency. So 5 here, raised to the power of 1. So each number raised to its frequency. That's how we obtain this. Then we'll go on, look. So when we when we multiply this, we multiply all of these, then we have a 11,520 rather. 11,520, and that will give us, when we look for the 8th root, it will give us 3.2187 approximately. Now, going on with that, we can obtain the, okay, so assume we can now obtain the harmonic mean. And what will the harmonic mean be? The harmonic mean is going to be what we are seeing here now. So n is the number of observations, and that's going to be 8. Then we will have each observation dividing its frequency. So the frequency of 2 is 2. 2 here, so we have 2 here divided by these 2. Then we have 2. The frequency of 3 is 2, so 2 here divided by 3. Then we have 4. Its frequency is 3, so 3 and 4 divides its frequency 3. And then 5, the observation 5, its frequency is 1. So 5 will divide its frequency. So when we do that, we are going to have 8 divided by 157 divided by 60. So if you like, you may add a bracket here. So now when you solve that, you are going to have, you can punch that on your calculator, and you'll have 3.0573, and that's that about that. All right, so having looked at all of these that we have seen, all of the kind of means that you can have, the types, there are certain advantages and disadvantages of the means. I would like you to look for them and know them, but I'll just give one. The arithmetic mean is sensitive to outliers. So when you have outliers, you may not know what an outlier means, but sometimes you may have values that are to the extreme. So for instance, you're having this now, and maybe there is an observation of, let's say, 75. So all the other observations are very small compared to this observation. So it's an extreme value. Right? On the other hand, so this outlier is an outlier that is extreme to the right. There may be outliers that are extreme to the left also. And one of such cases can be a case where you have something like 0.0009, or you even have something like negative 500. Now, looking at that, these observations are very small compared to what you have here. They are too small. So sometimes you can have extreme observations. Now, so we may not use something like 0.09. Depends on the circumstance in this case. But let's assume that minus, being to the left now, minus 500, you can readily tell that it is very, very small compared to the other values. So those are extreme values. So the arithmetic mean is affected. Let me not say sensitive. Let me say it's affected. It's easily affected by outlier values. So you could have 75 here, and when you divide, the mean becomes large. So you may think and say, okay, it means, for instance, if this is the salary of one man, 2 naira, this is the salary of another man, 3 naira, this is okay. And somebody is earning 75. Now, if you do a small calculation on that, you should have, I'm trying to do that now, you want to get the mean. Now, we originally found the arithmetic mean to be 3 point something. Now that we want to find the mean of this now, we will get something larger. And it's going to look like the people have been, okay, this was not the value we used, but okay, let me just quickly do that. 2, 3. These were not the observations we used to obtain, but let me just quickly do this. So we are looking for the mean of 75, 2, 3, 4, 1, 2, 5. And if you do that, you should have mean of x to be 13.14. So it gives us a value of 13. So the mean of all of these that you are looking at gives us a value of 13.14. 1429. But if we remove this outlier, remove this value, and we look for the mean of just these ones, of only these values. So that means the mean of 2, 3, 4, 1, 2, 5. So the mean of 2, 3, 4, 1, 2, and 5 will be, all right, let me quickly do that. We are going to get a mean of okay, 2.833. So that will be 2.8333. Now, looking at this, the mean of all of these numbers that you are seeing, 2, 3, 4, 1, 2, 5, and 75, was actually 13.1429. However, the mean of all these numbers, so minus, you're not putting 75 this time around, it will give us 2.83. So the mean of all these numbers will give us 2.833. Now you see that the difference between this number and this number is very large. So the difference between 13.1429 and 2.8333 is very large. So supposing these values are the salaries of some people in thousands now, and these are the salaries of people in thousands. So if you remove the man who is earning 75,000 naira, and we compute the average value, it's going to be very small compared to when we put the salary of the man earning 75,000 naira. And so somebody may compute the average salary for 1, 2, 3, 4, 5, 6, 7 now, and say, oh, the average salary is 13 point something. And he may feel like that's good, that's great, but he will not understand that it is actually just one person's salary that has made the average salary fat. So the arithmetic mean is affected by this. It's not too good. All right. Now, the disadvantage of geometric and harmonic mean. I'm going to mention just one. I will mention one, but you should go and look for the others. You need to find out about the advantage and disadvantages. Now, the geometric mean does not work well when you have a zero value. So if any of your observation is zero, the geometric mean will automatically be zero. The same thing applies to the harmonic mean or something similar. In the case of the harmonic mean, if any of the observation is zero, you cannot compute the harmonic mean. So why for the geometric mean, just imagine that x1 is 0. If x1 is 0, then it means that you will get a geometric mean of 0. It doesn't have, you don't need to have two observations to be 0. But as soon as one observation is 0, your geometric mean will be 0. Then for your harmonic mean, if any of the observations is 0, don't forget that what you are doing is n over. So look at this now. Imagine that this x1 is 0. Can you do a division of 1 can you divide 1 by 0? Or can you divide anything by 0 for that matter? It can't be obtained. So it means that the harmonic mean will not work well when any of the observations is 0. And in a similar manner, okay, not exactly the same anyway, the geometric mean will also not work for you when you have any observation to be 0. In this case, you are going to be getting 0. So your geometric mean will be 0. And it doesn't provide any useful results. It means you can't use it for anything. And you can, just as you cannot use the harmonic mean for anything when any observation is 0. So the arithmetic mean is what you have to turn to in that kind of situation. All right. So those are just a few. So to wrap it up, the disadvantages of the disadvantage, just one disadvantage of the arithmetic mean is that it is affected by extreme values, or you may talk about outliers. All right. Whereas the geometric mean is not useful for us when we have or may not help us obtain what we want when you have is a value that is 0. So it does not give much, or it doesn't give us useful information when it may not give us, it doesn't give us useful information when we have a value that is 0. So the harmonic mean cannot be computed. That's the disadvantage of the harmonic mean now. Cannot be computed when any observation is 0. So with that, we have come to the end of this class. Thank you very much.